Welcome back to Redstone with Dave,
And Baker.
doing Pistons.
Pistons. This is an example of a one-tick pulse generator. So basically, right now, this lever generates, well, as you know, a lever will output redstone for as long as the lever is flicked, right?
Right.
But what we can do, if we want it to only happen, if we only want a redstone signal right when the lever is turned on, we can do this. So this piston is right here. So basically right now, as you learned in the other challenge, this redstone here will power this repeater, right?
That's right.
But as soon as it powers that repeater, this piston's going to extend. So I'll just show you that.
Yeah, let's take a look. All right, okay.
So if you want to watch that lamp when I turn the lever on, it just flicks on. Even though this lever's still on, but now this piston is extended, and this isn't a solid block, this piston, so it can't go through and reach the repeater.
I gotcha. So the piston does not count as a solid block.
So basically, this, exactly. Okay. So this redstone lamp, it just turns on for one tick, so a 20th of a second.
Right. Okay.
And so one of the things you can do with that is sticky pistons need a little bit of time to extend and retract. So if you only power it for a tick, it gets powered so it pushes, but then it retracts before it's fully extended. Someone's having more fun than you, Dave.
Yeah.
All right. So, in this case, the piston is powered for just a second, and even though it's sticky, it gets pushed up and then retracted before it can pull the block down. So the piston moves faster than the block can move.
I see. Okay.
And so then if I do it again, you'll notice it retracts.
Right.
Makes sense?
Yeah. Okay.
Retracts. So then in this situation, we basically have the reverse of this slightly. So in this, when the lever is turned on, you get the signal. And in this, when the lever is turned off, you get a signal.
Because
so you see how the lamp turns off for a second?
Right, because of the inverter?
So the inverter is part of it, but right now this torch is powering the piston, which is why it's on.
Gotcha.
And this redstone is not. And so when I turn this on, you'll notice the redstone is powered, but this isn't, and so the piston is still extended because the redstone's powering it, right?
Gotcha. Okay.
But when I turn it back off, this torch takes a tiny bit of delay to turn back on. And in that second, this piston isn't powered, so it retracts the redstone block, which turns this dust off, unpowering the lamp for just a second. So to see this a little bit better in a similar fashion to the other one, we can do this, and you'll see that it just, so instead of, nothing happens when I turn the switch on, but when I turn it off, then we get our output. So you see the lamp and how on?
Yeah, I'm trying to.
So just, it's easiest to see if you stand here, actually.
Okay.
And so, and go up a little bit so that you can see the dust and the.
Yeah.
Yeah. So it just turns on when the lever is turned off. So basically, you get an output of a tiny bit of signal as the signal turns off. And in this one, you get an output of a tiny bit of a signal when the signal turns on.
Right. Okay. Okay.
And so then we can use that here to create something that's called a T flip-flop, which in my opinion is the best circuit name of all time because it's really obvious what it does. It flips on, and then when it gets power again, it flips off. So Press the button once. Redstone lamp is on. Press the button again. Redstone lamp's off. So basically, this button is now a very complicated lever.
Wow. I'm trying to take this all in. So the button to the redstone to... Okay, and then we have this on the other end. So when this goes up...
So this
so that
turns it into the 1 tick.
Oh, okay, because it gives
and
it
then
just
this
enough power.
piston extends and leaves the block here, which powers the lamp.
Okay, let me just see this one more time. Right. Ah, very clever, Baker. I like that.
I wish I could take credit.
Well, it's the first time I've seen it, so.
So now, we'll use that again to create a pulse extender.
Okay.
So basically, if you want to press the button and just watch the lamp.
Okay.
So it's on, it's still on, it's still on.
Still going.
And now it's off.
Wow. Okay.
So normally, when you press a button that's attached to a lamp, it just stays on for however long the button is pressed, right? So over here behind you.
Right. Where are you? Oh, there you are.
So this lamp is only on for a very short amount of time, right?
Mm-hmm. Gotcha.
So, but in this, what happens is we send 2 signals, and one of them is just really, really, really delayed.
Mm-hmm.
So we have the first button press, which extends this piston and powers the lamp, right?
Mm-hmm.
And then the other button travels through all of these repeaters, slowing down the signal. And then finally, after 2 seconds, or like 2 game seconds, because, this is 3 seconds. It gets here, and then it creates another 1 tick pulse, which retracts the block again and turns the lamp off.
That makes sense. Okay.
So, for instance, if you want an example of how to use this, like if you created a piston door using the pistons over here, and your button was really, really far away from the piston door, and you wanted to have time to get through the door, you could do this, and the door would stay open for longer.
Oh, you know, I really need something like this in my Minecraft world. That's perfect.
So, just as a very quick example, I'll get a torch, put that here, and I'll have a block there. And then we can have our 2 piston blocks here and our pathway. So if I had a normal button on this lamp right here, so I'm just putting a button here as an example, and I pressed it, the piston only opens and closes for a very short amount of time. So if I'm all the way over here, I press the button, and I try really hard to run all the way over there, I can't get there in time.
I have had this problem so often that I just...
So now...
This is great.
I can press this button and take my sweet... Oh. I did this in the wrong order.
It's okay.
Yeah, so this is... I just messed this up a tiny bit. Let's see. How can I fix this? Let's problem solving.
Yeah.
Here.
This is important. This is
here.
This is worth it.
Here. There. Yeah. So basically, all I've done is just invert the signal again.
So I can't tell you how many doors I've run into. You know, over and over.
So now, that door's closed. I press this button, and I run all the way over here. Oh wow! Look at all of this time I have. I'll just stroll through the...
Oh, snap. Okay. I'll hit it again for you. See, that's what I'm talking about. That's always what happens to me.
Well, I mean, I was just showing off.
Yeah, nice. Oh, that's great. That is going to be a nice custom addition to my Minecraft world.
All right.
Very cool. All right, so this is basically the so we have you know the basics of how pistons work, and then we have the one-tick pulse, the falling edge, the T flip-flop, the pulse extender. This is basically everything that you need to know about pistons in terms of the basics, right?
Yeah, and
Cool.
then this is just a very simple piston door. This is two sticky pistons next to each other.
Mm-hmm. Okay.
So,
Okay, great. Well, good stuff. We're making Minecraft worlds better and better here.